Welcome to Data Skeptic All About Surveys, our season about survey design, interpretation, and methodology. Let your voice be heard at survey.dataskeptic.com. I expect many listeners will already be familiar with James Randi and his $1 million prize offered for anyone who could demonstrate proof of the paranormal or the supernatural. No one ever got the money, and that prize is no more. I went down a Wikipedia rabbit hole tonight reading the List of Prizes for Evidence of the Paranormal page. The two most notable in my mind are the CFIIG, the Center for Inquiry Investigations group, as well as the Australian Skeptics having a similar prize. In any event, why do I find tests like that interesting? I think Randi liked having the test because it was sort of leverage. If he wanted to challenge someone making extraordinary claims, he could say, go prove it and we'll give you $1 million. Even if you don't want the money, you can give it to a charity. Now that's for cases where there's someone claiming something. I can see the future. Pay me a bunch of money to tell you your future. Different from scientific inquiry. To date, a lot of people have submitted for these challenges claiming to have ESP. And to date, none of them have. Although that doesn't prove ESP doesn't exist. In fact, there was a previous study that showed there might be a slight positive effect in one experiment, and we're going to talk about that today. Now, the key thing in science is that result reproducible? If it's a real phenomenon, you should find it in lots of different labs and under different conditions. I mean, the same experimental conditions, but it shouldn't matter if you do the test in the morning or on a full moon. Reproducible is reproducible, or it's not. And today we're going to discuss an attempt to reproduce that notable experiment and see if they can also detect ESP under the same lab conditions. Now that's interesting from a skeptical point of view, but why does this belong in our All About Surveys season? Well, of particular interest to me in their methodology is their use of surveys to get a consensus design. They worked with proponents and opponents of the belief in ESP to come up with something everyone could agree to. In fact, there's a couple of really cool features we'll get into, like they pre-agreed on the conclusion. I don't want to spoil too much, including the result. Did they substantiate that ESP occurs in a laboratory setting? Like Fox Mulder, I want to believe. But more than that, I want to know the truth about the world I live in.
I'm Zoltán Kekecs. I'm an assistant professor at ELTE Institute of Psychology. I'm a Ph.D. I have a Ph.D. in Behavioural Science. My research focuses on mind-body medicine interventions used in medicine and the mechanisms underlying the effects of these interventions.
Could you expand on that? The placebo effect comes to mind right away. Is that within your domain or things like that?
Yes, very much so. Our current study is, for example, looking at the effectiveness of hypnosis for pain management and how it compares to placebo hypnosis intervention.
Can you give us a quick preview? Does it compare?
So in our study, there was no difference whatsoever between the placebo hypnosis and the conventional hypnosis intervention in its pain reduction capabilities. But it doesn't mean that they were ineffective. So both of them were quite effective at reducing pain.
As placebos.
You can say that. But so one of the current interpretations or theories related to hypnosis is that it is a placebo on steroids. So placebos and placebos are different. So there's a difference between the effectiveness of a pure placebo for pain management and the effectiveness of placebo acupuncture, for example. So placebo acupuncture is twice as effective at reducing pain as a pill, like if you say that this is aspirin or whatever. It's even more effective if you do placebo surgery, for example. It's much more effective than the other two. So when you kind of cut up the person but don't do anything, just sew them back up and tell them that they had the surgery. So hypnosis can be thought of as even as an open label placebo, which empowers the person to act upon their expectations and their hopes for them getting better or getting the benefits.
Well, it's a fascinating field for sure. Well, the paper I invited you on to discuss today, you open with a rather provocative statement. You say, trust is currently in short supply in the psychology research community. Could you expand on why that is?
Yes, some of you might have heard about the replication crisis in biomedicine and social sciences. The replication crisis basically means that there's low replicability of the effects that you would read in the top scientific journals. Currently, the replication rate is measured at around 40 to 60%. That's pretty glim, if you ask me. That about 50% of the effects that you read about in the top journals is bullshit. So that basically makes people very skeptical in the research community, or at least in my bubble, about the trustworthiness of some of these research findings. And that unfortunately affects negatively the perfectly legitimate effects as well, especially, for example, on my field, which is usually treated with much skepticism, like mind-body medicine interventions. If people have the context that psychological science is in a turmoil of a replication crisis, they would probably think that it's better to assume that these effects don't exist, or they would not replicate.
How long has this been an active study going back in the literature?
Do you mean the replication crisis,
Right, like
or?
the crisis is something
Mhm.
that I think the media talks about. Was it whispered about and known, or is there this, Cambrian moment of, oh, everything's changed now?
Yes, I think the replication crisis was kind of ignited by this paper by Deribam in 2011, which was called Feeling the Future. So, this was a paper related to a parapsychological topic, in which Deribam showed in a series of 10 studies that people's choices and behavior correlate with future randomly generated events. This is kind of a non-committal way of saying what BAM interprets as people have precognition. The important thing is that this paper was published in JPSP, the Journal of Personality and Social Psychology, which is one of the flagship journals of social psychology, and also one of the top journals in psychological science overall. Probably when BAM published the paper, he thought that people would think, okay, if this paper is published in JPSP, then probably the claims are trustworthy. But it kind of backfired, because instead, most people's opinion was, okay, if this paper was published in JPSP, then we must be doing something terribly wrong, and we cannot trust any papers now. Yeah, so I think this was kind of the match that lit this big pile of garbage that was accumulating under our noses all this time. There were, of course, people who were talking about this. There were attempts at replicating some of the milestone or these cornerstone studies that we teach in our psychology courses and are in the psychology textbooks. There were some failed replications, but this was the moment when people kind of flipped out, and commentary after commentary and paper after paper started to appear on this subject, and people started to connect the dots.
Well, hearing, I think the number you shared was somewhere in the range of 40 to 60% are not replicatable.
Yeah.
I'm thinking about it from a statistical point of view. And if we use common tests, and look at p-values less than 0.05, then we should expect 1 in 20 studies doesn't replicate. Just that should be the rate. We're seeing a much more frequent rate. Is there we wouldn't expect 100% replicability, I guess. This is not the goal. Do you have a sense of what the goal should be?
Yes, I'm not sure how you calculated the 20%. Probably you have a better, like a mathematical reason for saying that. Like the intuition of common person would be that if we use a 5% alpha level, like 5% p-value threshold, then we would get like only 5% of our claims where we claim that there is an effect should be false.
Mm-hmm.
Obviously, for practical reasons, we would not expect 95% replication rate, but we would probably expect like something around 80% or something high like that. But we are nowhere close to that range. In some of the other areas which were subjected to some of these large replication attempts, have even lower replication rates. So there's one paper claiming around 20% replication rate in preclinical cancer research, for
Oh
example.
boy. Well, I can't imagine a problem that big has one simple reason and root cause. But do you have a sense of what some of the common reasons are for lack of replicability?
Yes, there are some usual suspects, so to speak, which are nowadays called questionable research practices. This is one line of thought about what are the root causes of this low replication rate. The other line of reasoning goes into like mathematical necessity. If you so it involves the publication bias, like there's a high selection bias in the literature. In the top journals you would find some journals with 95% or 90% positive findings, which seems pretty like hard to imagine that people would be that good at doing research or formulating hypotheses.
Yeah.
If you take into account the publication bias and the base rate or hypotheses being good or bad, if you account for a low base rate of good ideas, good hypotheses, then you could produce a 50% ish replication rate together with publication bias. There's a very good paper on by Ioannidis on this. Why most published research findings, are wrong. But most people in the reformist movement in psychological science tend to blame the questionable research practices for this low replication rate, which would include, for example, harking, like formulating hypotheses after the data are known. Um, so you collect data from 50 different variables and then see which ones are significant, and then only publish the five of them or the three of them which turned out to be significant, and claim that you hypothesized all along that these three would turn out to be significant.
I thought that was called machine learning.
Yeah, exactly. There are some similar problems in machine learning as well. The good practitioners of machine learning know about all of these pitfalls, and usually they experience it in their own skins, like when I meddled in some machine learning projects. But most people in social sciences don't get that first-hand experience of what problems related to overfitting and having too many variables, having a very low signal to noise ratio, and so on.
Well, I think one of the strongest suggestions, I don't know if you would associate it with the reformist movement you'd mentioned or if it's a new idea, but attaching a better protocol to these steps can remove a lot of these challenges and criticisms that have arisen. Are there now formal schools of thought around better protocols, or is this a new way of thinking?
I'm not entirely sure what you mean by better protocols. So, research protocols, I think we have overabundance of textbooks on research methodology which have best practices listed in there. And if you would read the papers, you would think that the researchers, and if you trusted what they wrote in the paper, you would think that they use the best methods there are. But the issue is that there is no way of verifying that they actually did what they claim to do. That's one of the issues that come to mind when thinking about using good protocols and verifiably using good protocols.
Well, if you want to set out on a replication yourself, can you talk about some of the standards you would hold yourself to?
One of the things that I would definitely do is contact the original authors and make sure that I understand exactly what they did, and try to replicate step by step their procedure. So when I would do a replication, I would want to exactly copy their procedure to the extent that it is possible in my laboratory. One of the issues is that the current standards of detail in the reporting of the scientific papers in psychological science is not high enough so that people can exactly replicate a scientific project without contacting the original authors, except for a few cases where the design is very simple. Oftentimes, you would have to go to the original authors, and it is not high chance that they would help you.
Did you approach the BEM team, whose paper we were talking about earlier?
Yes, we actually involved Dario Bem and a panel of other experts in designing our study. Yes, so when we originally submitted our research proposal, then we contacted Dario Bem, and he was excited to help us to replicate this project.
You'd mentioned, though, earlier that not everyone would be. Some people might, I don't know, see that as territorial, or I don't know what the reasons would be. It sounds like this was a friendly interaction. Could you talk more about the process?
When contacting Dario Bem, I just sent him an email talking about our idea for doing this replication. But when inviting the other experts, we used a more systematic approach. So we use something that we call a consensus design process, where we use the Delphi survey to design or fine-tune the research design in our research study. And we invited them based on a systematic search of the stakeholders on the field.
If saving more and spending less is one of your top goals for 2023, why are you still paying insane amounts of money every month for your phone bill? Switching to Mint Mobile is the easiest way to save this year. As the first company to sell premium wireless services online only, Mint Mobile lets you order from your home and save a ton. With phone plans starting at just $15 a month. You know, at that price point, that is an outstanding extra phone for a developer for testing stuff. We've been messing around with some SMS stuff, and I think this would be a great way for me to set up some test lines at a very affordable price. On top of that, I should hit up Linda about switching over. I'm sure we could save some money here. If you're looking for extra savings this year, Mint Mobile offers premium wireless for just $15 a month. By going online only and eliminating the traditional costs of retail, Mint Mobile passes significant savings on to you. Unlimited talk and text, high-speed data delivered on the nation's largest 5G network. You can use your own phone with any Mint Mobile plan and switch easily in minutes with eSIM. To get your new wireless plan for just $15 a month, and to get the plan shipped to your door for free, that's mintmobile.com/dataskeptic, where you can cut your wireless bill to $15 a month. mintmobile.com/dataskeptic. This is what qualifies as the survey component of our interview today, so I want to expand on it a little bit.
Yeah.
Something that was interesting to me amongst these experts is you have proponents and opponents. So you're collectively going to design this protocol, but when you're coming from different schools of thought, in some sense, how do you come to that consensus?
I would start by talking about how were consensus procedures done originally before the Delphi process came along. In these consensus procedures, to my knowledge, come from medicine, where there are some areas where there's not too many research data or not too many studies that have been conducted. So there's not a very firm ground on which to base best practices. However, there are a lot of experts on the field, or a few experts on the field, who have specific domain knowledge. They have met a lot of these people with this particular illness, or they have used this particular intervention, and then you would put them together in a room somewhere. Maybe there's a conference where this is convenient, or you would fly them to the same place. They would take a few days to come up with best practice guidelines for treating this illness or to use this particular intervention. But there are inherent problems with coming to a consensus this way. For example, we know that in a group situation like this, where you have very different opinions, then there will be polarization of the opinions, and people will not come to a consensus. Rather, their opinions will diverge. Also, if there are some key figures like influential people on the field in the group, the others will tend to stick to them, like gravitate towards their opinion. And you won't get an unbiased view from all of the experts on the field. So all of this comes from the in-person nature of this type of consensus conference. What the Delphi procedure does instead is every expert is participating in this consensus process individually. They get an initial survey. For example, if the goal is to come up with a list of guidelines to treat an illness, then they would get get an initial list of the guidelines that the coordinators thought about to start the process off with, and they would be asked to rate each item in the list in a Likert scale, for example, on how useful these items they think are, or how important they think it would be to put these in the final list of guidelines. And importantly, in this survey, the experts are given opportunity to express thoughts about this item could be improved this way, or you should put in these 3 extra items because they are missing from the list. The Delphi survey is an iterative survey. So after the first round of the survey, the coordinators would aggregate the findings and see where the group stands at thinking about these items. They would incorporate the suggestions of the experts in the panel and design a new list of items and send this back to the experts. Importantly, this reactive Delphi survey that we used also includes a component where the experts get feedback about the other people's opinions. This way, they can get a sense of where the group is standing as a whole and where are they at the process of coming to a consensus. This is done anonymously, so there's none of those group effects that I was talking about. Maybe 2 people who are opponents in the real world or they are adversaries in the scientific realm, they might find themselves agreeing in most of the point. But if they were in person in a room, that would never happen.
Aha.
So this is the basic idea of the Delphi survey. And at some point, the coordinators would say that, okay, we have reached a conclusion where we have enough consensus. Ideally, they would pre-formulate the stopping point of the survey. Like we would stop at reaching this high ratings for this many items with this range of interquartile range or dispersion in the data. So we used this same process in our study, but instead of formulating a list of guidelines, we submitted our research protocol to the expert panel. We first formulated like a first draft of our research proposal. We asked them to rate the methodological quality of this process, of the protocol, and its secureness against questionable research practices, fraud, and other types of research biases that are known on the field. We also gave them a free text field where they could say, okay, here's how you could improve the protocol. That's why I rated it a 5 on the 0 to 9 scale. And I think you should do this to improve that rating. And the iterative part came in where we collected all these ratings and opinions and then tried to incorporate all of the feedback of the researchers and then sent them back the new iteration of the research protocol, which was now rich with detail, including their opinions, and asked them again to make the same ratings as before. And also importantly, we gave them feedback about every other member's opinions, their free text responses, their ratings, and the distribution of the ratings over these scales. So one of the cool features, I think, in our consensus design process is that we not only ask the researchers to rate the quality and ask for improvements in the protocol, but we also ask them to rate the conclusions of the paper that we are proposing. We wanted the panel to express their opinions about each possible outcome of the research study
Aha.
and what would be the conclusions of the paper. Because usually what you end up with is, okay, this study was designed great, but the results can be interpreted in 1,000 different ways.
Sure.
But in our case, we specifically asked the panel members to express what they thought about 3 types of possible outcomes for this study. If we find a correlation between the previous behaviors of the subjects and the future randomly generated events. If we don't find this correlation, and also if we find inconclusive results.
How many rounds did this survey process go on for?
So it only took 2 rounds. This is pretty typical in Delphi surveys.
Uh-huh.
Usually the Delphi surveys stop at 2 or 3 rounds. And we have pre-registered and pre-formulated or stopping rules. So it was not like at the second round, we just felt like stopping because we didn't want to continue.
What could you describe some of the differences between the first draft and the final?
I think our first draft was naively short. We didn't include enough details. In the second draft, we had to go into very, very specific details about like the exact priors that we would use in the Bayesian analysis, the settings of the statistical models. We would talk about the exact image pool that we would use in the stimuli that we give to people. Not only there were some new features added, but the main difference was, I think, in the level of detail that we had to provide. And I think that was a very important improvement on our protocol, because otherwise these little details would have been usable later to kind of torpedo our findings or a study,
Sure.
mention post hoc criticism.
Well, I like the process a lot. Through this, you've interacted then with some proponents of ESP. I guess these are people who think this is a real phenomenon that can be scientifically measured. To me, that's a little surprising at this point. I thought there's been a fair amount of negative research about this, but maybe more so that I don't know of any proposed mechanism for it. For a long time, people didn't know what the appendix did, but it turns out the appendix doesn't have anything to do with ESP. I don't know of something that looks like a wireless transmitter in the brain, but I'm not a neurologist. Is there a mechanism that the proponents believe in?
I'm not a parapsychologist myself, so it would be hard to say what are the current mechanisms that are the primary candidates. But most of the explanations, as I understand, have to do with quantum physics, because that's a realm of uncertainty and a lot of undiscovered potential. So usually these fringe explanations tend to use this area for explaining some of the effects. I wouldn't like to offer something that is actually not really believed by the
Fair
researchers
enough. Yeah.
on this field. So sorry that I can't indulge you in that
No worries.
area.
Well, even without a mechanism doesn't stop us from taking a measurement.
Yeah.
One of the things I really liked about the design was, as you'd mentioned, there were pre-registered conclusions and I guess a consensus that given X results, it's conclusion A, B, or C. Could you talk a little bit more about that X? What was the ultimate litmus test that was being awaited on through the study?
For this, I would have to explain a little bit about the research design.
Yeah.
We replicated experiment 1 from those 10 studies I talked about in the original paper. This experiment is very simple. People see 2 curtains in front of them on a computer screen, and they are told that one of the curtains hides a picture, while the other curtain hides just a blank background. They have to guess which curtain holds the image. They make a guess, either left or right curtain. Then, unbeknownst to them, there's a randomization process after they made their choice, deciding which is the correct answer, whether the left or the right curtain is the correct answer. If they responded correctly, then they would get to see the reward image, which was incidentally an erotic image, because Ben thought that there must be like a evolutionary psychology explanation for the development of these ESP abilities. So one of the greatest rewards that we can use in this type of study is like an erotic or explicit he actually used explicit pornographic images. So if the person did not guess the correct side, then they would just be shown like a gray background behind the curtain. The ultimate test was whether there would be a higher than chance guess rate or correct guess rate in the sample. By chance, we would expect 50% correct guesses. in the original study, BEM reported 53% correct guesses, which was statistically significant. So it was not a huge effect by any means. And I think it's quite on the verge of breaking even in a casino in roulette, for example. So if that was true, you wouldn't get very rich from playing roulette, even if BEM's findings were true. We used a combination of frequentist and Bayesian inference to make our final test. And this was one of the outcomes of the consensus design procedure, because originally we only proposed the Bayesian test, but for some reason, many of the consensus design members insisted on there being a frequentist test, like a test against the p-value in there. So we ended up implementing a hybrid hypothesis test, which is I don't know of any other studies where they do this. So we said that if both the Bayesian and the frequentist test has the same conclusion, supports the same model, then we would make a conclusion in that direction. So either accepting the hypothesis that there's a correlation between the choices and the later randomly generated events, or if both of the models say that the null hypothesis is supported, then we would conclude that. If there's anything between, so only one of the models support one or neither of the models support any of the two models, then we would say that the test was inconclusive.
Well, one of the neat aspects of the protocol you described earlier was that it's anonymous. So whether I'm an opponent or a proponent, I don't see what my peers are necessarily saying. That means that maybe this Bayesian frequentist debate, did it fall along so-called party lines, or was it more random?
I didn't observe party lines. I saw proponents of the frequentist and proponents of the Bayesian on both sides.
Interesting.
But it doesn't make too much of a difference, in my opinion. Given enough data, they would return the same conclusion.
Yeah. Well, pre-registering the protocols and the conclusions and the tests are nice steps, but I know there's more work that you guys did as well here. While you're conducting the replication study, you're collecting data the whole time. Can you talk about your protocol aspects around data collection and storage?
So the main point of our study was to basically empower researchers to be able to demonstrate the trustworthiness of their research findings, of their data and their procedure. And of course, the readers of the paper to be able to verify this trustworthiness. So what we did, we applied a combination of a series of different methods to ensure or be able to verify that our data have high integrity. It was not meddled with during the process. Data collection software was unchanged during the data collection period, and so on. Some of the aspects that we applied were related to increasing the transparency of the procedure. Some were related to automation, and some were involving external oversight. So I would say that we use the combination of these three main aspects: increased transparency, automation, and external oversight, to patch up this transparency gap where people, the researchers, previously couldn't be sure what happened during a research study. An example would be that we used something called the direct data deposition, which means that our data, as it was being collected, directly pushed to a version controlled repository. We use GitHub for these purposes. So instead of the data being collected in pen and paper or on a laptop or a pen drive somewhere, or data immediately ended up in a repository, and importantly, a version controlled repository of that. The raw data in its initial form is always available, and any changes are traceable through this process. We used a similar approach for our data collection software. So we used Git to version control and track our data collection software, so it is verifiable that we didn't make any changes in the software, like introducing a small bias in one side of randomization, or taking into account the person's choices in the randomization process. So this is the automation part. We also use increased transparency, for example, through something called the born open data, which just means that our repository, data repository, was open public from the get-go. So people could use our data and analyze it as it was accumulating. We also use something that we call real-time research reports. There was a Shiny app trained on the data that we're accumulating. It provided a live feed of our research findings, which provided interpretation of our data as well. People who are tech savvy and stats savvy, for them this is redundant because the born open data provides them with the data and they can just do the analysis themselves. But most people wouldn't be able to do that. And for them, there was this real-time feed of our research findings while we did the study. And we also used external audit in our study, which basically means that we employed auditors, research auditors, and a software auditor who checked our IT processes and or research procedures, that everything was conducted as we claim they were. There are a list of other things as well. If you want, I can go into some more detail.
Sure, yeah. I mean, the paper has a ton. I don't know if we can cover every single one because there's a lot of thoughtful commentary. But if you want to highlight one or two others that stand out, that would be cool.
Yeah, so what I can also kind of just put out there, that we used the previously already established best practices on the field, which basically encompass pre-registration, meaning that we registered our protocol in a repository before starting data collection. We also used open materials, so all of our materials or software code are available also in a repository. We also used experimenter manuals, which were designed for the experimenters, and checklists to allow them to deliver the protocol as intended. And one of the things that are very rarely used in psychological science, we use video verified training of the experimenters who were in contact with the participants to be able to show, verify to us, but also to the readers, that the experimenters in this study were well trained in delivering the protocol. This was a multi-site study. In these situations, it is important. I mean, it is hard for the central coordinating team to be sure that every site has the proper training. So that's why we implemented this video verified training of the experimenters.
Yeah, it sounds complete. You can always go back and review the video.
Yeah.
Well, one thing that occurs to me is that as a participant, maybe I don't want to see the gray background. I want to see the erotic picture. And if I just have a streak of bad luck, I could get frustrated that I'm not getting the prize and I could quit. And then there would be a survivorship bias to the people who were lucky to begin with. Can the protocol account for that? I don't know that it even happened, but could it handle it?
This is one of the number one reasons for having so high positive effect rate in the parapsychology literature. The researchers don't really account for this aspect. If you think about gambling, you might be aware of some gambling strategies with which you can ensure on a long run profit for a gambler. For example, if you are playing roulette, there's a strategy: place a bet, and you would always double your bet until you win, and then you would basically quit and go to the other casino. So this way you would play until you're winning. You double at least double your original money, and then you would go to another casino. But in parapsychological research, this is not usually treated with enough suspicion. So if there is a person who has a bad streak and they would quit, it would be usually just that person's data would usually be just simply excluded from the data set. Or even worse, they would just use the data that was provided until the point that they participated in the study. This would create a bias in the data. Let's say that your strategy, knowing that your data would be used until the point that you participate and no longer, could be to play the game until you are winning. Let's say you would start the experiment and immediately stop when you have your first failure. That would create an artificial inflation of overall successes or high percent successful participants in the data. But the other side of the coin also exists. So if people have a bad streak of luck and they leave the study, and you would exclude every data of the participant who did not finish the series of trials that you wanted to subject them to, these people would be excluded, and your analysis would be blind to some of the unsuccessful attempts by people. And this would create the artificial positive bias in the data. So in our protocol, we overcome this by analyzing every single data point that is ever collected in this study without consideration of the participant who provided that data. You can show that this basically overcomes the issue, the bias produced by these two different approaches. So we take into account all of the trials, and the trials are assessed individually, or more or less as if all of the trials were produced by the same participant. We also use another statistical technique that takes into account participant, like we use a linear mixed model also in our statistical procedure, which would be important if ESP was correct, and there's a difference in people's ability of ESP. You can imagine a scenario where there are some very talented people who have ESP. In this situation, it would be important to take into account the participant's person and that certain data points come from the same person. But the linear mixed model is less susceptible to the sorts of biases that we talked about just now.
Well, with all of the pre-registration and agreeing in advance on how to do things, was there much work to do once the study was done?
Yeah, so that was one of the cool things about our study, that once we had finished data collection, we just had to basically plug in the data and submit the paper. There was a lot of work in the front end, but on the back end really saves you a lot of time, especially as we also implemented the real-time research report, which basically had the results section of our paper. So we even had it implemented, how we will plug in the data once they are collected. Most of the work was done on the discussion section, which explains our experiences while implementing these methodological best practices.
Well, what did this methodology teach you about ESP? Do some of your respondents have it?
Our study did not confirm BEM's original findings. In fact, our data supports the null result, the null hypothesis. Basically, we found 49.8% hit rate. So it was very, very close to the chance level, 50%. It satisfied all of our preset criteria for supporting the null model, which basically says that people cannot see into the future.
And this was true from both the Bayesian and frequentist point of view?
Exactly. So both models had the same conclusion. We also did some more exploratory analysis into the thing that I just talked about the possibility that there are some people who have more talent than others.
Could be.
And there's also an interesting hypothesis or theory in the ESP literature concerning sheep and goats. One of the reasons that many studies don't find an overall effect in the data, there are some people who are very lucky or very talented, some people who are very unlucky or very untalented. These people just cancel each other out in the overall results. So we were making explorations in this area as well. Again, this was one of the aspects that were requested in the consensus design process, and we didn't find any indication of this either. So the distribution of the results was pretty much what you would expect by flipping coins a lot of times, binomial distribution.
Given that you came about these conclusions following the consensus design, did everyone involved in the process agree firmly with the conclusions?
That's something that we should discover or assess in the future, because the consensus design panel members were not usually part of the study itself. So some of the panel members did join the data collection effort, but most of them did not. So we will send out a survey to ask about how they rate the paper and the conclusions that we drew, and whether they agree with these conclusions now with the hindsight.
Well, interesting. Yeah, I'll be curious to follow up on what the result is there too. Although, when you follow the protocol, Seems like there would be consensus on the results, I would hope.
Yes, I also hope that, but I'm very interested in seeing the results as well, because a lot of time has passed since the consensus design process was concluded. So some people might have changed their minds.
Could be. Well, I know also in some of our back and forth, you'd mentioned that you're working on a project where maybe a developer could implement a trustless survey platform. I just was hoping maybe we could wind up getting a few details on that. That's a curious idea.
Basically, our procedures that we used were all custom made. So our data collection platform or Git push, everything was set up by a developer for this particular purpose. Most of the researchers out there in my field, psychological science, would not have the programming expertise to implement these on their own. The direct data deposition, born open data, the tamper evident software technique like the version control, the data collection software, all of this would be beyond their capability. So they would have to hire a programmer to do this for them. But it shouldn't be too hard to create a platform which would do all of this seamlessly. So this is a project that we are working on right now. So this would be a platform that is similar to other experimental software or survey platforms out there, like Qualtrics or ePrime or OpenSesame, but with the capability of implementing or features like direct data deposition to a trusted repository like GitHub or OSF or some other repository, or own repository for that matter. We would be able to track and verifiably show that the survey or the experimental software did not change during the process. And it has a lot of other potential. For example, so the long-term vision is that whenever you read a scientific paper and you see a number there, you would be able to click on that number and you would see what is the experimental the code, the statistical code that produced that number. You would be able to see the raw data, or if the researchers, for some reason, don't want to show the raw data, you would still be able to verify that the raw data was unmodified, or that the code verifiably produces that number through our system.
Very cool. I definitely want to keep my eye on this project as it develops. I think you'd mentioned you're looking for volunteers. Is there anywhere people can follow it online?
People can email me or find me on Twitter. I guess you might have that in the show notes, or I can.
We will for sure, yeah.
Yeah, so it's my name at ppk.alta.hu, my email address. If you search for Kekecs on Twitter, there's only one, I think.
Well, Zoltán, thank you so much for taking the time to come on and share your work.
Thank you so much for inviting me. It was a pleasure.
Well, that's it for this episode, and I'll see you next time on Data Skeptic All About Surveys.